So the objective will be to actually cover up the concept of definite integrals in the next around 15 minutes or so. So when you look at the indefinite integral and definite integral, the difference between both of them is that you will see simply, let's say, an indefinite integral will be, for example, something like this. Integrate x cubed dx, and so you write down the answer as x to the power 4 over 4 plus c. While when you have a definite integral, which is always with the boundaries, you will see the boundary conditions where like you will see that there is a limit to the values. So a and b. Now let's say if you have f of x dx. So whenever you integrate now, for example, let's say if I integrate x cubed dx from let's say 1 to 5. So what happened is that in this case, we integrate this. So it'll be x to the power 4 over 4. And normally, like normal integration, don't put the constant here. Now, what we actually do is we take this is 1 and 5. Okay. And after that, this will be, you substitute the upper limit. This is always the upper limit, and this is called as a lower limit. So if I plug in the upper limit here, so if I plug x as, 5, so it'll be 5 to the power 4 over 4, and subtract with by plugging 1 here. So 1 to the power 4 over 4. So this is going to be 5 to the power 4 is 6 to 5 minus 1 over 4, which is nothing but this is 624 over 4. So this is the difference between definite and indefinite integral. That your first thing is that you don't put a constant here. You don't put a constant. Only reason is that if you put even though if you put a constant here, it will be plus c, and like and at the end, if you subtract the both of them, it eventually get cancelled. So we don't need constant here in the definite integral. So number one is that when you evaluate this, there is some significance of this value that you have got. Now let's just simply try to look at this on like calculator and see how it is different. So now when you look at a simple aspect is that if you plot the x cube function, that x to the power 4 function actually, so x cube function which we've integrated, and our limit of integration was from 1 to 5. So I'll just first make sure that view window is big enough. Now, if I show to you what does integral represent, and now to do the things on calculator or integration on calculator, you'll have to press G solve, and then you go under integrate, then you go under integrate once again. And if I put x as lower window as 1 and upper window as 5, you will notice that this actually gives you the area bounded by that curve, the x-axis, and 1 and 5. So actually, when you look at the in context of the question, if I have x cube graph, now the significance of this is, suppose this is the x cube graph, and now if I take this 1 and 5, so this value that you have got is actually the area bounded by the graph, which is f of x, x-axis, and these two lines. So it's now we'll be also using integral as a tool to calculate the area bounded and all. But before we do that, we'll understand the properties of definite integral in much detailed way. So that's the first thing, is that when you evaluate the integrals just as outcome. So suppose if there is a function f of x and with the limits a and b, if you integrate this, so assume that the integration is g of x, and so you put a and b here, and it'll be g of b minus g of a. And this won't be always the entire area, but provided the function is above x-axis, this can be blindly taken as a area, but area is a little complicated concept. So linking up the definite integral will directly area also will be a cautious step. So we'll discuss that in later part. But just now, to evaluate the definite integral, you're gonna first integrate whatever the function you get, put the upper value, put the lower value, and subtract them. So a couple of interesting properties of definite integral is, if you have f of x integral as some value, uh, but if I change the limit, instead of a to b, if I make it b to a, what's the relation between these two? So obviously they will be the numerically negative, because instead of uh, the upper here, you're putting the lower first. So obviously, what are the answer you get? Suppose this is nothing but g of b minus g of a, as discussed here, g of integrated function. And this will be basically g of a minus g of b. So obviously, you can see they are exact negative of each other. So so when you change the limit, just the value of the integral actually becomes numerically negative, or opposite of what it was earlier. So consider that this value was 10, this value is 10, this value is going to be negative 10. That's it. Now that's about switching the property of integral. Now next up is breaking down the integral in several subparts. Now for example, if an integration is a to b, I can actually break down this between a to c f of x plus, from then c to, let's say, d f of x, and then at the end from d to, let's say, b f of x. So you can break down or collapse the integrals based on the values that it is in between. So let's say this is a and b, and here is c, and here is d. So if I want to find out this entire area, that is integral of the function from a to b, which is this, or I can do first thing is I can find out the area from a to c, that is this area. Then I find out the area from c to d, that is this area. Find out area from b to d, this area, and add them up. It's the same thing. So this can also be collapsed, like, these two integrals. You can join these integral limits, and it becomes integral from a to d f of x dx plus integral b to d also d to b f of x dx. So it's up to you how do you tackle the limits of the integrals, but this is how exactly you will get the, like, in case if you have to squeeze the limits and all, that's how you do it. So this is like the standard level type question. So suppose if the function has been f of x and g of x, these are the two functions. It has been given that 1 to 3 f of x is -2, 1 to 5 f of x integral is 7, and 1 to 3 g of x integral is 3, and 1 to 5 integral is 5 for g of x. You have to find out the value following integrals. So let's say if I have to integrate 3 times f of x minus g of x from 1 to 3. So what I can do is I can firstly split this integral. So I can take 3 outside, 1 to 3 f of x minus 1 to 3 g of x. And so 3 times, if I now look at the integral of 1 to 3 f of x, this value is -2. So it'll be 3 times -2 minus integral of 1 to 3 g of x. So 1 to 3 g of x is nothing but 3. So it'll be -6, -3, which is -9. So that's it. That's the value of the first integral. Now the second one is, if I have to find out, let's say 1 to 5, here the limit you can see has been flipped. I don't have any limit that is starting from 5 and ending at 1. So what you can do is, if I look at, I have to find out the value 5 to 1 f of x minus g of x. This is going to be exactly negative if I make the limits opposite. So 1 to 5 f of x minus g of x. Now, what I can do is I can split them up. So put the negative outside. An integral of 1 to 5 f of x minus 1 to 5 g of x. This value is nothing but negative 1 to 5 f of x, which we got already, is 7, and minus 1 to 5 g of x is 5. So it will be 7 minus 5, and that's 2. 2 of negative. Negative of that is negative 2. So that's the exact value of this integral. Now the next one is find out the integral of 1 to 3 5 minus 4f of x. So in such cases, what we do is integral 5 minus 4 f of x from 1 to 3. So you can see that there is this 5 is on its own. So first you integrate 5 separately. So 1 to 3, and minus 4 you separate 1 to 3 f of x dx. Now you already know this value is 1 to 3 f of x dx is 1 to 3 is nothing but negative 2. So it'll be negative 4 times negative 2 here. And then 1 to 3, integral of phi dx will be 5x from 1 to 3. So now you plug in x as 3 here, x as 1 here. So it'll be 5 into 3 minus 5 times 1. Remember that the integration of a constant, as I had told in the beginning, is c times x. So that's what I've written here. So 5 3s are 15 minus 5, and minus become plus, so it'll become 8. So this is nothing but 10 plus 8, which is 18. So that's the answer of this particular example. So in some cases, what will happen is that you're not given the limit of the integral, and just you're given the value of it. So in this case, you're definitely going to integrate it. The first step is like do the normal integration, put the limits after that. So like put m in terms of m and 0. Anyway, if you plug 0, you'll get the same answer. So it'll be m squared minus 4m equals to negative m, and then you solve for the integral. Next up is, the same thing. Again, the same b part is the same integral, but limit now has been evaluated. The value of this has been given to 5. So you get two m values, which is m is 5 and m is negative 1. So there are two answers that are possible for the upper limit in this case. So for this problem, once again, you integrate like when you have the integration of like 2x plus 3 to the power half. This can be half plus 1 or half plus 1 and times 2. And then you put the limits as 1 and 3. You get the exact value, which comes out to be like here. The second one, you don't attach ln and all, because that's a common mistake you do. So you take up, the integration of this will be 2 times 3 minus 2x to the power negative 2. And then you integrate this from 0 to k. So take 2 outside, integral of 3 minus 2x raised to negative 1 over negative 1 times negative 2, negative 2. So dividing by this negative 2 is coming because of the coefficient of x. And then you put the limits 0 and k, and you'll get the exact value. So in one of the most interesting part that you get is like assuming that you have understood integration by substitution. I would just pick up this kind of question. There are more couple of questions like here. You can practice this on your own. But let's say a question where you have been given the limits, like generally for x values. Let's say the integration is root sine x times cos x. And if you do this problem by substitution, in this case, it is important that, let's say, I'll just explain it. In this case, it is important that you change the limit once you make the substitution, or you do this problem without limits, and at the end you substitute the limits. Because the common mistake that students do is, I'm going to show it to you. So let's say integral is root sine x cos x. The focus is too much on the integrating function that they forget the limits, changing the limits. Now here the limits of the integral is for x values, which is pi by 6 to pi by 2. So when I take, let's say u is sine x, because its derivative is multiplied along with this, so which I covered in my previous part. So du by dx is going to be cos x. So in place of dx, I can put du over cos x. So when I integrate this now, it becomes root u cos x times du over cos x. So cos x and cos x cancels, and you get integration of root u du, which is u to the power 3 over 2 divided by 3 over 2. And then the common mistake that students do is that even after changing the limit in terms of u, they'll put this as pi by 6 and pi by 2, pi by 6. And then here also, they put pi by 6 and pi by 2. This is absolutely wrong. Because remember that you are taking this is the limit of x, and in place of u, if you're taking, then it is going to be wrong. So what's the additional step you need to do is only one single thing, is that since you know the relation between u and sine x, what you do in the beginning itself, when I substitute, change the limit, you can see that the moment substitution has been made, they change the limit from pi by 6. So if I take x is pi by 6, yeah, so we all know that sine pi by 6 is going to be half. And similarly, sine pi by 2 is 1. So this limit, instead of pi by 2 to uh, pi by 6 to pi, you change it to half and 1. So once I do that, final integral is like if I put half and 1. So if I integrate this is what we got the integral. If I put 1 here, now this you get. And then I put a half here, you get this. So this is one way to evaluate it, the integral. Second way is that you don't put the integration at all. You don't put these limits at all anywhere, neither these limits nor these limits. So you integrate as if you're integrating indefinite integral. So integration of square root of sine x times cos x dx. After doing the substitution, I assume that you come to this step upon 3 by 2 plus c. So here you do as if you're doing indefinite integral. So after you do this, now take u as your sine x, so sine x to the power 3 by 2 divided by 3 by 2. And now you put the limits. If I want, the integration of this is this. So I mean, integration of this function is this. So now I can substitute the limits pi by 6 and pi by 2. And now, you know, since you're putting the original limits and the expression is also in terms of x, you really don't need to worry about. So that's the only like, you know, part that you need to be aware about when you're doing the definite integral.